Our last speaker for today is Mr. Jorge Benetiez, Managing Partner and Co-founder of Enzyme a.p.d. Hong Kong. Mr. Jorge, please.
Hi, everyone. Good afternoon. Hi, everyone. Thank you, BCA, for inviting me here today. And thank you, Graphisoft, as well, for the opportunity of speaking in this forum. I'm very, very excited. So my name is Jorge Benéitez. I'm a Spanish architect. Everybody in this part of the world knows me as George, so that's why I was introduced as George. And I live in Hong Kong, where I have my company, but we recently opened as well a branch in Singapore, so we operate from the two countries. And my company is called Enzyme, and we're mainly designers and architects. But with the time, with our experience of the last 6 years, we have also become some sort of like digital consultant and technology advocates. So we are a small but international team, and our idea is to bring together this very good design as well as efficiency and innovation, which sometimes they're not going together in architecture. We have the chance to work with really good partners and clients, some of them in Singapore as well, and we're very excited to see that after 2020, a terrible 2020, 2021 seems promising, and there are a lot of opportunities starting everywhere. And I agree with one of the previous speakers that almost we need to thank COVID for pushing some of this digitalization forward and faster during this last couple of days. So just a super brief introduction. We work in BIM. That's our media. We don't work in any other platform. So since the beginning, we have been using BIM for our design projects, our construction projects, and for us, it's just a working methodology that works for every single scale. So from really large urban design and master planning scale projects to more like architectural design, towers, condos, cultural projects, residential, to pure interior design projects. We've been using BIM, leveraging the power of data-driven design in each of these different projects. So for us, BIM is, as I said, a methodology that can be applied since the very beginning, since the very first sketches. You can have a data-driven and model that you can interrogate even for like the most simple parameters. So we do that for our own projects, and then we also support other companies that are willing to experiment and to implement smarter design workflows. We had a really good experience as well. There was a speaker from Takenaka here today, and we are really proud of calling them our friends as well. We spent 2.5 years with the Osaka office working together and developing incredible projects and very, very smart workflows. So Archicad is the platform, is the backbone of our workflow, is our software of choice, and we not only use Archicad as a BIM software, modeling software, but also as a platform to integrate all our workflows. So yes, we use Archicad mainly, but we in our daily work we incorporate information and geometry coming from very, very, very different sources. So from Grasshopper and Rhinoceros, which is also our main say like fork of tools that we use to for example, tools that leverage as well data like Elephants and Wallacy from the Grasshopper ecosystem, or environmental tools like the Honeybee and Ladybug set as well in Grasshopper, and many other softwares in visualization field or in the BIM collaboration and quality control as well, that enable us to share that data, quantify, do the quality control, and then visualize in different ways. And we are big believers of this open BIM approach to like this very wide open BIM approach to the projects and to the industry. And we are very proud to say that we have had really successful collaborations with other partners that work in very different platforms, integrating as well their work in together with ours. So some of the speakers today were talking about cloud-based systems and companies running in or moving into cloud platforms or non-presential platforms, and I'm really happy to see that this is happening for us. And this was just due to the fact that all my partners and I and now my colleagues are from various different places. We have been operating in the cloud since day one. So all our servers run in Dropbox and in the G Suite, in the Google Suite. We have internal communications running on Slack, and we have a really big company database for projects, clients, and other management items that runs and gathers data from various sources that it's called Airtable. We use Google Data Studio, for example, to display and create a data visualization to understand some of those metrics that we are trying to leverage. And we have one amazing tool that is the Graphisoft BIM Cloud as a service, that is a cloud platform to share our BIM projects, to collaborate with internally within the company, but also externally with partners and other consultants. So today my talk is about data-driven design, and I'm gonna give the approach from our side, from the side of the design and from the side of the architecture. So obviously, this new technologies like BIM, digital design, or data-driven design are changing really the way that we are, the architects and clients are approaching the work that we have been doing for years. And we have to embrace all those changes, or we're happy to embrace and to push them forward. As for us, all these technologies just makes this whole design process more flexible, easier, more understandable, and more participative for both designers and the clients. And we think that that's a really positive thing. So what is for me this data-driven design? We have, or I have these two approaches to data-driven design. So first of all, it's a process, or it's a set of processes that improve the decision-making in a project, gathering data from different sources, analyzing that data, and also optimizing the project towards certain goals that are tracked. And then there is another approach to it for us, which is just the fact of where and how all that data lives and goes and moves from phase to phase across the project lifecycle. So ideally that is maybe a centralized platform where different people, different stakeholders can input and output data throughout the whole lifecycle. So in terms of the first approach, there are like hundreds of different tools that are popping every day online, or larger architectural offices or digital consulting firms are creating all these impressive and magnificent tools for gathering data from or different models, not only BIM, but also like Rhino models, or I don't know about SketchUp, to be honest, but other softwares as well, and that are there just to support these data-driven decisions. One of them is this one by Proving Ground. Proving Ground is an American company that it's specialized in digital consulting, and I really like this one especially. So I'm just going to jump quickly to it. So this is again similar to some of these dashboards that we've been seeing before. This is just like a live website. I think it's powered by Power BI from Microsoft, and all this data is coming from their Rhino models. And through this plugin that they sell, you can pretty much access to all the different information and metrics that you set up as a designer or as a consultant. This can be obviously shared online, and it's quite impressive. So you can, for example, establish, I don't know, certain metrics and certain interactions, and be able to share these with clients, consultants, etc. And this will definitely help for, you know, some of the issues that we've been hearing in the previous presentations about not being able to meet physically and having to push meetings online, or making decisions you know, in separate places. So this type of tools are really useful for that. So so yeah, coming back to my presentation, for us, for example, we use that approach, and we always try to establish the key factors and the key metrics on the projects that are important to follow through, and one of them obviously, or some of them obviously are more important in the design phase and the construction or tendering phase. So there are different tools that help us in doing this. One of these tools obviously is Elephant. It's a great plugin for data mapping and data creation in Rhino. There are other tools that we use called Wallacy also help us to create goals, and it uses this genetic algorithm that it's able to optimize different algorithms and data models towards meeting certain constraints or certain goals in the project, and I will tell you a little bit more about that later. Even in the basic tools of the BIM toolset, like in Archicad, for example, we have for example automatic schedules that can, you know, even like simple schedules from the beginning of the projects can help us as designers and architects get into this new approach that is this data-driven design. We've been always tracking, for example, things like GFA since everywhere. I mean, since a long time ago, many years ago. But now we have a tool or tools that enable us to track every single small decisions that we make. So we just set up a simple schedule, and then we start designing without really without being preoccupied that we will need to go and measure and understand. So it's just sort of like establish the rules beforehand, and then you can design freely and in a more flexible way. This is again this Wallacy tool from Grasshopper, and you can see here how this particular tool takes an algorithm that is built in Grasshopper, establish certain goals and certain parameters that need to be maximized or minimized, like, I don't know, like sun exposure or amount of materials or distance through, I don't know, different exits, you name it. Anything that can be quantified can be set up as a goal for this tool. And then the machine will run through millions of different options and checking all these different parameters, and it will not only do that and give us all these options, but will also give us information and graphics and metrics for us to understand how these multiple solutions are affecting each other. Because in life, in architecture, most of this, when you try to optimize for certain performance in one aspect, then it will be in detriment of other aspects of the building. So most of the time we have all these contradicting objectives that need to be evaluated in certain ways. So sometimes you will pick the average, sometimes you will favor one goal or one metric over the others. So all these tools help us track all this data and all these different solutions throughout these millions of options. In our work, for example, we've been working lately with some hospitals in Africa, and we are trying to move into this approach of as well tracking these key metric aspects in different ways, and being able to we are now or this project is in a very preliminary state, and we are comparing various and very different design options. So we are using, for example, a tool called Airtable that together with the data that is coming from our BIM models and our drawings, it's able to create this data analysis and this data, like small data visualization widgets that we can share with our clients and discuss, and it really helps the discussion on whether they go to develop one type of hospital or another. So it's really useful. I really recommend, if you don't know this tool, Airtable, it's free to use under certain stage, of course, and it's really, I think, the first step towards understanding this whole concept of how relational databases work. So and one thing that we are exploring as well, and that we're very interested in, is all these tools, like, for example, Google Sheets or Google Data Studio or Airtable. They have open APIs that are REST APIs that can be accessed, for example, through simple Python code, and can be connected, for example, to our Archicad API. So at the moment, this is something that we are also researching, but it's really interesting. How can you get all this information automatically from Archicad, push it into the database, and then share it in other multiple platforms? So there are other tools as well that are helping us to create and to move the data through the different platforms. For example, Drofus or Speckle or GitHub, they are creating, or they're starting to get into the construction, the AEC industry, because obviously there is a lot of improvements that can be done in our industry. And again, if you haven't looked into these platforms, I recommend you using it. For example, Speckle is an open source tool that enables data transfers in any type of data structure through different tools. So, for example, from Excel to Archicad to SketchUp to Rhino to Revit. So it creates this almost like seamless connection. In our in our software of choice, which is Archicad. Archicad belongs to the Nemetschek group. And in the Nemetschek group, they have this whole new concept that is called the building lifecycle intelligence, very in line with the previous presentation, which pretty much tried to create a database or a centralized database of building lifecycle information to be accessible from all stakeholders along the entire lifecycle of projects. So coming back to Archicad, for example, by using the API that has been open a couple of years ago, the JSON Python API, and even the old C++ API can access and import and export data to all these different platforms. Some of them, they have like direct connection through plugins, and some of them they have this open connection via JSON and Python. We personally use the Grasshopper connection all the time, Airtable as well, and we're exploring other different options. So it's very exciting how all these tools, and especially Archicad, it's opening up to all these different platforms through the API. The tool that the Nemetschek group has that I think it's more in line with this whole concept is Rufus, which is a big database that is present, or it's supposed to be present in the whole life cycle of the project. So from the very beginning, the planning stage, it will gather the data and data requirement and information that can be used and can even automate the production of the BIM models up to a certain stage. And it will gather and make available this information through the whole life cycle. So just taking a few notes from Victor Vacconi, which is the Chief Division Officer at Nemetschek Group. So this building lifecycle intelligence enables this efficient cross-discipline coordination during the building lifecycle. So that is one of the objectives. The other one, it's to store and to have this cloud server-based database where any BIM tool from the group or external can sync to that central database. So then we will break this whole this whole problem of having data in silos. It was also mentioned earlier, and also ensures the consistency of the data, because there's like one database that has the single source of truth, and we are able to maintain that information for longer during the whole project life cycle. Obviously, all this needs to have an open, connected ecosystem that is structured in a way that any software can, like not only BIM softwares, but also external to the AEC industry, they can just like, bring in and out information to this database. So there's a little bit of work that the whole industry has to do in order to just agree on to these open standards. Coming back to the design aspect, for us, for example, this data can come from anywhere. So things like, and this is also related to a few of the projects that we've done. So data coming from GIS that we can analyze using different tools in Grasshopper, and then apply certain designs, and using Wallacey we can create multiple iterations that are optimizing for wind flow, for external comfort, for sun exposure, etc. So all this data, it's used at the end to create what we call performative design. So it's projects or aspects of the design that are performing to improve certain parts of the or to achieve certain goals in our design. So in our case, for example, in this project, we were just using a very simple script to track all the shadows throughout the year and optimize a building facade, reducing the amount of material, reducing the depth of the sun shading system, and at the same time creating an architectural language. So for us, it's all combined into one, towards one goal, which is improving the quality of the projects. In terms of, for example, other projects, we in this case, this is how we implement this whole kind of data-driven design from the beginning. So this is a particular project that we were leading for a stadium, football stadium, and the whole initial shape was parametrically designed based on this real-time data, based as well on data coming from, as I said, different sources. In this case, official dimensions from the different sources, and this whole thing combined with environmental aspects, location, wind, etc., gave us the first initial shape of the building and the ball. Then we send all the data back to Archicad, but first of all, we didn't have the appropriate tools to send all these panels, as they were most of them, in this case, they were double curved. So prior to the rationalization work on this project, what we do is send it through what we call morphs, which is just like a mesh element in Archicad. But using this this data-driven approach, we are able to classify, to add information to all these to all these panels. That it's not a bin element per se, but it can become part of this open bin workflow and gather and be a container of information of material, classification, IDs, and different other custom properties that we can embed on them. These shared, in this case, we shared it through IFC to the other consultants, and it was very useful to in downstream down the line, right? After that, we continue the development of those the shape and the structural behavior, and using as well computational tools in Grasshopper. We created this whole spatial truss system for the stadium. And lately, something that we are doing that we find really interesting is the creation of custom objects in Archicad. They are called GDL, Geometry Description Language, is the programming language that is used to create these objects. And these custom GDL objects allow us to expose parameters in this case in the Grasshopper tool. The GDL have identity, improve performance as they act as instances. They enable to integrate different workflows inside because they are parametric objects, and it speeds up the work and the documentation as they are also they can behave independently from the 2D visualization and the 3D. This is something I think very special from Archicad. So we developed these panel objects that can be exposed, as I said, in Grasshopper, and they can expose any type of attribute or any type of property that we are able to generate in Grasshopper. And Grasshopper is an open source tool that connects pretty much with anything via Python or different other programming languages. So you can effectively find information and read information from any database and input it into these information containers that are these objects. And then we can use the objects in Archicad in many ways. So they obviously work very well for documentation, for scheduling. This is just an image of one of the corners of the stadium. And then I will show you now how they also help to track information, track data, and embed that data inside. So I'm going to show you a different project. In this case, the project was not developed in Grasshopper and was not developed through this data-driven design process. But once we came into the detailing and construction documentation phase, we decided to start using, in this case, Grasshopper, because we really needed to track and to make efficient certain parameters and certain aspects of the design. So I'm going to talk about this blue Voronoi shaped ceiling in the middle of the screen. So in this case, just very briefly, it was a false ceiling, part of the one aquarium that we are designing. And obviously, the ceiling was designed in that way because it had several reasons. One of them, it was obviously to follow some sort of like conceptual aspects of being underwater. But then it was also because the room where it was located, it had a very complex geometry and a multi-directional approach where we couldn't really use easily any other baffle ceiling or any other more rational ceiling. So we decided to go through this. But obviously, after the design phase, where this ceiling was generated using a random algorithm, that was randomizing the shapes and the sizes of these panels in order to create that very fluid and very natural look. We obviously faced during the construction phase that it was very difficult to define, very difficult to document, and obviously very, very expensive. And we decided to step back and rationalize it. So we use this plugin that I've mentioned before called Walacy. And in Walacy, what we did is we created in Grasshopper, you can see now on the screen, a number of goals or number of parameters that we wanted to rationalize. In this case, for example, small edges or very large edges into this whole Voronoi pattern. We connected it into the program, the Walacy, and then we connected as well which parameters or which sliders we were willing to say use in order to optimize this. So for example, in this case was the location of the points that were generating the Voronoi diagram, right? So after running the algorithm, and after, as I said before, this was a multi-objective problem with conflicting objectives. So we tried to set up our problem, our algorithm in a way that they work together, mostly, and not against each other. And we at the end we were happy with one of the proposals that this AI tool was giving us. And what we did is we after we had this optimized diagram that was easier and more efficient for fabrication and assembly, what we did, you can see here how all the smaller edges that we were tracking and all the larger segments that we were tracking were within the range of what was available as material. And another aspect of this project, and this was done using this other plugin that I mentioned before, Elephant, it was not only to optimize these elements, but also to add information that would be useful down the line. So names, things like colors or angles that will be relevant to the different nodes, things that can be scheduled later on inside the BIM tool. So we created all this set of data inside the Grasshopper, and then we use this. So you can see here that inside Rhino and Grasshopper, we had all the data mapped out, and even we had almost the documentation ready. But we wanted to bring this into our main file that was an Archicad file. And what we did is we created a very dummy GDL object. So just creating a simple geometry with simple modeling tools and saving this as an object in Archicad. So it's really a 3-click job. And these elements that we created, we use them as containers of information. So this is an approach that we learned in this project that is being really, really effective. So you can access to these objects in the Grasshopper side. You can input any parameter or information that we want from the Grasshopper side. And you can also place the location of the elements. So that can be automated as well from Grasshopper. So pretty much this was giving us all that we needed, not only for creating a more realistic and more accurate 3D model, also for coordination and for class detection, etc., but also having a very data-rich model that later on can be scheduled, later on can create automatic documentation, etc., etc. So all these objects, they were located using a very simple script that you have on the screen. So the orange elements on the screen are the Archicad objects that we created, and the rest of the script is just sort of like funneling information into these different elements. So at the end, what we did is we use something that Archicad has that is called labels, or smart labels, I called it, that can, you select a bunch of elements and you select the parameters that you want to include in that label, and then automatically that label is going to read those parameters from the object that you are attaching the label to. So because we had already imported and did all this data inside those simple elements, then all the documentation process was extremely easy and accurate as well. And you can see here, this is the final a part of this final model that we use for coordination. So this is what I had prepared for you today. I have one more thing, actually, that it's a small video of a R&D project that we are preparing. And this R&D project is a prototype of a Grasshopper plugin for Archicad that is we are developing in-house, that uses the Python and JSON API that has been opened lately, in order to access data from the Archicad database in Grasshopper and manipulate that data without having to create new geometry, which is one of the limitations that we have right now. So it's just a very, very simple video. If you allow me a couple of minutes to play. So you can see just these simple 4 walls that have been created in Grasshopper, and we bring those walls into Archicad, sorry, into Grasshopper. I think it's a little bit too fast. So what we do is we bring the elements using this wall component that it's already included in the Archicad Live Connection suite. Then using one of our new components, we can choose to which Archicad instance we want to connect. We can connect to one, the other one, or both of them. So this enables workflows that can enrich not only one Archicad model at a time, but maybe a multiple set of instances that are open. We can, for example, find all the walls in all the different instances open, and then embed some information, or then check or extract some information, which is really useful. Once we do this, what we do is we find, using one of our new elements or new nodes, we can find, so we have to put the element type that we want to evaluate. So in this case, without plugging anything, we have access to all the standard Archicad properties that are available in that specific file. And then we can, what we do is we start inputting what we call in Grasshopper sliders. And this is only to filter from all the available properties, only the one that we need. So we want to filter for element type, like for example, in this case, walls, and then the inside all the properties that are available for walls, you want to choose, for example, in this case, the ID, right? And then you connect the elements that you want to evaluate and change. And then that gives you, as a result, the result of the property that you're looking for. In this case, it's the wall ID. It's very simple, and this is already available. But what we can do in here is we can create a small algorithm. In this case, that's going to just create a new ID. So this is like a very simple and dummy algorithm. And then we can just we have another custom node that we have created that it's able to override the properties that we have selected with new values. In this case, we are connecting the property that we chose before, and we are connecting the new values, and we just run the tool. And in Archicad, you haven't seen it, but it actually changed the value to this new wall ID. And we can just, and it runs live, so we can just change immediately to a new name. You will see the change as well in the feedback screen in Grasshopper, and then automatically will change in Archicad. So that is such a simple exercise opens up the possibilities, the infinite possibilities of connection from any database, from any tool that it's able to connect to Grasshopper, which are most of them, to import and export data out and in to Archicad, right? And then all this data, then they will be streamed into this whole OpenBIM workflow and then shared with other consultants, other stakeholders in different manners. So this is something that we are really trying to master and trying to push forward in our practice. So thank you so much. And well, now, yes, thank you. You can contact me. My details are there in the QR code and on the screen. And if you have any question, I'll be around for the next half an hour or so. Thank you so much.